Hello, welcome to this week's problem of the week. For this problem, we're looking at the number of sequences, A, B, C, D, and E, where A, B, C, D, and E are all positive integers, such that the product of all five integers is greater than or less than or equal to their sum, which is less than or equal to 10. So the way we're going to count sequences is to look at sequences based on how many ones they have, or how many integers in these are equal to 1. So as you can see, we just have the number of ones on one side of this column and the number of quote-unquote good sequences on the other side. A good sequence is one that satisfies this criteria. So we look at first a sequence with 5 ones. There are only 5 integers in the sequence, so that would mean that there's only one possible sequence with all the ones, and it satisfies the requirement because 1 to the 5th power is equal to 1, and that is less than 1 plus 1 plus 1 plus 1, which is 5, and that is less than or equal to 10. So we have one good sequence with 5 ones. Now we look at a sequence with 4 ones. So if there are 4 ones, that means that there is one integer that is greater than 1. And there are 5 possible integers we can set as the integer greater than 1, because we can have a equal to, or a greater than 1, the remainders equal to 1, b greater than 1, rest equal to 1, and so on. So there are 5 possible integers that we can have be greater than 1. And then now we look at what values this remaining, or the integer greater than 1 can equal. And because we have this condition where the sum must be greater than or less than or equal to 10, we have 4 ones. So the remaining integer greater than 1 has to be less than or equal to 6. So that means now that we've set the conditions that it's greater than 1 and less than or equal to 6, we say that there are 5 possibilities for the remaining integer, and that is 2 through 6, which is 5 possibilities. Once we have 5 possibilities, we can set any integer, one of the 5 integers, to be that possibility. So we know that there are 25 good sequences if there are 4 ones. So now we look at a case where there are 3 ones. To do that, we're going to look at this condition to figure out which pairs we can have for the integers that are greater than 1. And so we will do that right now. So as you can see, there are only 5 cases whose product is less than or equal to 10, and that's 2 times 2, 2 times 3, 2 times 4, 2 times 5, and 3 times 3. And you can check the sum, and you'll see that all these pairs work with that as well. And so now, with this in mind, all we have to do is consider the order, which 2 integers we pick for the values of this out of A through E. So for 2, 2, and 3, 3, it's fairly simple. For each of them, we have 5 possibilities. We pick 2 of them to be either 2s or 3s. 5 choose 2s equal to 10. So for each of these, we have 10 possibilities. And for 2, 3, 2, 4, and 2, 5, again, we pick 2 of these to set as greater than 1. But then we have to take into account order, because these don't have the same digits. So we, again, do 5 choose 2. But we multiply that by 2 factorial to take into account the order. So it's just 2 factorial times 5 choose 2. In doing this addition, we see that there are 80 possible good sequences if there are 3 ones. And finally, if we have 2 ones, that means that there are 3 integers, who have or whose value is greater than 1. And we have to keep into account the fact that we have to multiply them together and be less than 10. And given this condition, the only value that the 3 non-1 integers can take is 2. And given this, all we have to do is figure out what 5 choose 3 is equal to. And we'll find the number of possibilities, or possible sequences, that will satisfy these conditions. And again, 2 cubed is equal to 2 plus 2 plus 2 plus 1 plus 1. These are both equal to 8, and that is less than 10, so both of these work. So again, just writing it all down, we can only have 2, 2, and 2 as the remaining integers. And there are 5 choose 3 ways to, 5 choose 3 sequences with 3 2s and 2 1s, and so the number of good sequences is equal to 10. And having said that, the only way that works with the 3 remaining positive integers is if they're all 2. We can say that if there's only 1 1 or there are no 1s, then there are no good sequences, because if there are, or the smallest remaining value for the non-1 integers is if they're all 2, and 2 to the 4th power is 16, and 2 to the 5th power for 0 1s is 32. So no good sequences for 1 and 0. And so now we've counted up all the possibilities for each case, and all there's left to do is to add them together. So that gives us our final answer of 116 sequences that satisfy the criteria above. Thank you so much for watching this video. Be sure to subscribe to our YouTube channel, follow us on Facebook and Twitter, and check out our website, centerofmath.org. Thank you.